For this question, we have to use combustion analysis to figure out the empirical formula. So one thing that I should mention is for these kind of questions, we are going to focus mostly on organic compounds. So those are compounds that contain carbon, hydrogen, and sometimes oxygen. There may be some other compounds that contain nitrogen, but in those cases, it will be very clear what the products are. Even in this one, actually, they tell us the products are carbon dioxide and water. The thing that you need to understand is all the carbon that is in the carbon dioxide here, all the carbon that is in the carbon dioxide came from the carbon in the sample, and there's no other carbon here. So the carbon here in the product should equal the carbon in the reactant. The hydrogen here should equal the hydrogen here because there's no other source of hydrogen. Oxygen we cannot figure out because there's probably oxygen here and there's oxygen here. So for now, we'll leave oxygen as it is. So the first question is calculate the percent composition by mass for all of the elements in the sample. Okay, the percent composition of carbon in carbon dioxide equal mass of carbon divided by mass of CO2. We know the molar mass of carbon is 12.01, and then the molar mass of carbon dioxide is 44.01. Multiply that by 100 and we get a percent composition of, we do the same thing for hydrogen. So hydrogen in water equal mass of H divided by mass of H2O. That would be 1.01 times 2 divided by 18.02. And then to get the percent, we'll just multiply that by 100. Above here, we know that we have a total of 31.154 grams of carbon dioxide. That means that 27.3 of it is carbon. And up here, we have 7.977 grams of H2O. That means that 11.31% of that is hydrogen. So let's do the math there. Okay, so we are at the point where we need to determine whether this compound is made of carbon and hydrogen only or not. We remember here we're told that the total mass of the compound was 9.394. If this compound only contains carbon and hydrogen, the sum of these two values should give us this value. Okay, and if it doesn't, then that means that we have more. And that would require us to make the conclusion, or to come to the conclusion that there's oxygen there as well. Okay, so when we do the sum of those two, okay, so that clearly means that we only have carbon and hydrogen in this compound. I know the numbers are not exactly the same, and that has to do with the significant figures that we used as we carried this through. But it is obvious that this value is smaller than this value. So that means that there's nothing else in there. For the percent composition of carbon, we will have the mass of carbon, which is 8.505, divided by the total mass. I'm just going to use the 3.99 here, multiplied by 100. And then for that of hydrogen, it will be the mass of hydrogen, which is 0.894, divided by 9.399, multiplied by 100. This gives us 90.5%, and by default, this one should be 9.5%. Now we have the percent composition figured out. We can now do the empirical formula. So we have 90.5 grams of that and 9.5 grams of that. Okay. When we convert this to moles, we'll have 90.5 divided by 12.01, and we'll have 9.5 divided by 1.01. We have 9.417 here, and then on the other side we have 7.53. So now we're going to calculate the mole ratio by finding by dividing by the smaller of the two numbers. When you look at these two numbers here, you're not going to get whole numbers, so let's give it a go. So we have 7.535 divided by 7.535, which of course is 1, and then here you have 9.417 divided by 535. Here it would not be good for us to round this down to 1, because obviously this is 1 is to 1.25, and it will be easy to see that as 4 to 5. Okay, so the empirical formula here will be C4H5.